Okay, let's look at simplifying, first of all, expressions where we would be using the Pythagorean identities. So on the board here, I have four examples. The first one, cotan squared minus cosecant squared. If I had to simplify that expression, what I would want to make use of is some of the identity or Pythagorean identities that I know. I usually look for that in any situation where I have adding and subtracting of trig expressions where squares are involved. You'll notice that all of these have adding and subtracting where some squares are involved, and those Pythagorean identities become really useful. So cotan squared minus cosecant squared. I showed you before that if you have cosecant squared, you can rewrite cosecant squared and look for it on your formula sheet as 1 plus cotan squared, because that's what cosecant squared is. And then if you rewrite it that way and do a little bit of algebra here, the negative gets multiplied into both, or we're subtracting all of this expression, and the cotan squares cancel, and this whole expression is actually just equal to -1. The second example, we got -4 sine squared subtract 4 cos squared. Now, I'm familiar with the fact that sine squared plus cos squared is equal to 1. And so I'm going to make use of that here. I'm going to say if I pull out a common factor of -4 out of this whole thing, I would get sine squared plus cosine squared left behind. And the nice thing about sine squared plus cos squared is it's always equal to 1. So this whole thing is a messy way of writing the number -4. On my third example here, where I have cos x subtract cos x times sine squared, I'm just going to do a similar reasoning here. I'm going to pull out a common factor of cosine. If I make that factoring possible, so if I say I can pull out a common factor of cosine, I'm left with 1 minus sine squared. Well, since sine squared plus cos squared is equal to 1, then that means that 1 minus sine squared is actually equal to cos squared. And so we're going to make use of that here and say this is cos x times cos squared x, and that gives me cosine cubed. In my fourth example, secant squared x minus 1 over cosecant squared x minus 1 all square rooted. I had to stop the video and fix it because my original one that I had up there didn't actually simplify. It was a mess, so I fixed it up. So if you're wondering why it doesn't match what was up there before, it's because I fixed it. So if this is our expression for Pythagorean identities, secant squared x minus 1 and cosecant squared x minus 1, what we're going to make use of again is if you have 1 plus tan squared, it's equal to secant squared, and 1 plus cotan squared is equal to cosecant squared. So if we look at that carefully, then secant squared minus 1 is actually tan squared. And cotan squared would be cosecant squared minus 1. So this whole expression here, secant squared minus 1, we can just say it's tangent squared. And cosecant squared minus 1, well, that's actually the same as cotan squared. If we're looking at this carefully, then if you remember that cotangent is really just 1 over tangent, then if we have 1 over cotan, that's the same as just tangent. So instead of dividing by cotan squared, I'm going to times by its reciprocal, or tan squared. And so that gives me tan to the 4th, which, if you square root, ultimately gives you tan squared. A little bit of a trickier one for sure. But there's 4 examples of simplifying expressions using Pythagorean identities.